GLM5. 2 pushes acceptance length through 4 cumulative optimizations. Each one attacks a different source of disagreement between the draft and target models. Step 1. Architectural sharing. In a naive speculative decoding setup, the draft model is a standalone system. It has its own KV cache, its own internal representations, its own view of the context. But the target model has already computed high-quality representations of the full context during its most recent forward pass. Those representations encode precisely what the target model thinks is important. GLM5. 2 integrates index share and KV cache sharing directly into the MTP layer. The draft model reuses the target model's key-value pairs and indexing decisions, instead of maintaining independent state. Acceptance length lifts from 4.56 to 5.10. Step 2. Rejection sampling. The second optimization changes the acceptance criterion itself. The naive approach uses argmax matching. If the draft model's top-ranked token matches the target model's top-ranked token, accept. If not, reject everything from that position forward. Rejection sampling replaces the binary check with a probabilistic one. For each draft token, the system computes the ratio of the target model's probability to the draft model's probability for that specific token choice. The output quality is identical. The speedup is free. Acceptance length climbs from 5.10 to 5.29. Step 3. Total variation loss. The first 2 optimizations work around the gap between the draft and target model's distributions, add inference time, but neither one shrinks the fundamental distributional disagreement itself. GLM5. 2 trains the draft and target models jointly, adding an explicit total variation loss term to the training objective. Trained independently, a draft model optimizes for accuracy against the ground truth, predicting the correct next token. Trained jointly with TV loss, the draft model optimizes for agreement with the target model. The draft model learns the target model's idiosyncrasies. It learns where the target model hedges, where it concentrates probability mass, where it spreads it. The 2 distributions converge during training, so they have less to disagree about during inference. Acceptance length pushes from 5.29 to 5.47. Each step sounds incremental, less than 1 token of improvement across all 4. But these fractions compound on every single generation step, across every worker, across every question. Now put all 3 inference optimizations together and trace what happens to a real workload.